Starting now. So welcome to the first TGIFHacks of this semester. This is also the first TGIFHacks in our three-part series on data science. So in today's workshop, you will learn the basics of data science and how to do data manipulation and visualization. In next week's workshop, we'll teach you some advanced machine learning techniques like supervised and unsupervised learning. And then next week, we'll have Shopee down to teach you guys how they apply data science in a real life. So that's also a great opportunity for you guys to come down and network with Shopee and find out about any job opportunities that we have. So before we start, I would like to bring your attention to two things. First of all, during the workshop, if you have any doubts or any questions, you just raise your hand, and the closest committee member will come to you and help you out and convey your questions to the speaker. Second of all, for the materials for this workshop, you can scan the QR code on the right here, or you can go to link, links.ntuoverset.com/workshop. There you'll be able to find the materials that we'll be using for today's workshop. Let's get started. I hope you enjoyed today's workshop. So today's workshop will be done by Wilson. He's a second year undergraduate computer science major, and he has a lot of experience and knowledge in data science, artificial intelligence, and machine learning. So I hope you guys enjoy the workshop, and without any further ado, let's have a loud round of applause for Wilson.
Okay. Okay. Hi everyone. How's everyone's day? Good. Hey, those who have a good day, raise up your hand. Okay. That's good. Okay. So just now, Lash asked you to go to the link. So for now, all of you just type in the link and go to this GitHub. Go to this page. Give you a few minutes to do so. If any of you are having problems, raise up your hand. Okay, can. So after you are at this page, right? Click here, clone or download, and then download the zip file. After you download the zip file, unzip it, go to data. You'll see 3 data files. These are from HDB website, data.gov.sg. So basically, this website has all the, not all but most of the data from Singapore that is out there in the public. So future data scientists, you all can go to the website and take your data. Okay, anyway, once you all see these three files and you'll see another one is the IPYND file. Okay? So after you all see this, go to your Google Drive account. Sign into your Google Drive account and create a folder called TGIF Pandas Basics. Who is lost at this point in time? Okay. So basically, the first thing you guys need to do, I repeat, okay? First thing you guys need to do, go to the link on the right hand side. Your right hand side, and then you will reach this page, this GitHub page, and then the next step will be to press clone or download, and download zip file. Okay, after you have downloaded the zip file, unzip it, and then you will have these files inside. create a new folder in your Google Drive and upload the later. Okay, you all create a new folder inside your Google Drive first, and I'll tell you what files to upload.
Can you switch back onto the main slide also?
Oh.
Like that one should also show back to you.
Oh. Okay, who is done? Raise up your hand. Okay, wait for a few more people to be done first. If any of you need help, raise up your hand. The committee members will come over and help you.
People who don't have this collab, right? You have a list of all the prereq libraries. All the libraries.
They don't want this. You have to have
Seaborn.
you have to use
Just type it.
yeah, because you make it easy.
Okay, so you got your Pandas, Matplotlib, seaborn, scikit.
Yeah, it's all this, like you see.
Okay. Now I'll move on, okay? Everyone okay? Who's still not okay? Okay, for those who have not followed so far, you all can follow the steps below. So 1.2, at the GitHub page, right? 1.2 will be the instructions for first timers. So you all have never tried, you all don't know what is Google Colab, you all can follow these instructions. For those who have tried using Google Colab before, you all can follow these instructions. Okay? Okay, now I'll move on. Okay, so after you guys have created your folder, right? Go to here. You will find a HTTP resale price.ipynb. Drag this file to the new Google Drive folder you just created. So it should be something like that, something here. Okay?
People are having problems uploading it from their Google Drive. So can you tell them to go directly to the Google Colab website and upload it there directly to their computer? Yeah, like if you go on Google Colab, you can say upload.ipynb file. So like upload it directly there through Google Drive. Like this one alternative for those people have that problem.
Oh, I've never done this before.
No.
I always done it through
Oh, okay.
Google Drive.
Yeah, they can upload it directly through there. So you can tell them
Okay.
to upload it through if you're having problems.
Okay, who has problems uploading your IPYNB file to Google Drive? Raise up your hand. No one, Okay, can. So after you do that, for first timers, when you all click this, you all click the HDB resale price.ipynb, you all see an open with. Okay, so what you do is, you open with, there's a, okay, when you click open with, you will see select connect more apps. Okay, when you see that, you search for collab, then you press connect. After you're connected, you select open with Google Collaboratory. Okay? Bear with us for a while, okay? Because the setup part is usually the most troublesome part. After this, it will be smooth sailing. Oh, okay. Okay, some of you have the problem where you cannot upload your IPYNB file into your Google Drive, right? So what you can do is search Google Colab. Go to the first link, collab.research.google.com. And then you can select upload at the right hand side, and then upload your file inside. These are for those who have problem uploading their IPYNB file directly into Google Drive. Okay, is everyone at this page? Everyone here? Those who are not here, raise up your hand. Committee members, can you help? Continue raising up your hand. Okay, another raise of hand who is still not at this page. Who is still not at this page? Okay, those who still have problems getting here, continue raising your hand. The committee members will come to you. Okay. For the others, okay, your next step is to go to the zip file that you have unzipped. Go to data. Select these three files inside data. and then drag it over to here after you have pressed files. So initially you will have this. So you click on this little arrow at the side, at the left side, left hand corner. You click on the arrow, you go to files. After you click on files, then you drag the 3 files into there. Okay? Then you'll see something like this. Okay, a show of hands who has not yet uploaded the 3 data files into here, the left hand corner. Okay. Okay, who else still needs help? Everyone is here? Has the 3 files uploaded already? Okay, can. Okay, let's continue. So, today, as you guys may know, we are having a data science workshop, okay? So, data science is a very big field, okay? But first, what we want to do is that we want to give you all a solid foundation on what data science is about, okay? So, today we are using Colab, but usually people use Anaconda. It's a Python distribution that has most of the data science libraries pre-installed. But in our case, we use Colab because Anaconda distribution requires quite some time to install. So we don't want you guys to just come here and wait for like half an hour just to install Anacondas. That's why we use Colab. Okay, so Colab is basically a bit like Anacondas. It's like an environment, Python environment for you guys to do your work, do your data analysis work. So as you can see, it's different from an IDE because it has things called cells. So what these cells do is like, if you look carefully, you can have like compartmentalize your code. Okay, so that's the reason why it's very good for beginners and very good for data science to showcase their analysis. Okay, so before we get into how to do the data science analysis, I'll first tell you all about what is the data science process. So the data science process consists of 6 steps. Okay, so the first one is problem statement and shaping. So this is usually the hardest step. A lot of times you all have to create your own problem. Like for example, in our case, HDB resale price. What is affecting HDB resale price? You can ask this question. What is the factor that affects HDB resale price the most? Okay, but in our case, it's a bit easier. So our problem statement, because we are still teaching you guys the basics, so our problem statement will be how does floor area affect the resale price of HDB prices. Okay. So the next step is data collection. This is also another so for those aspiring data scientists, right? Don't just think that data science is all about playing with numbers, making very beautiful graphs. Actually, most of the work comes from data cleaning and processing, because that's where, most of the work comes from data collection, basically. So you all have to put in a lot of hard work. So 90% of the hard work, 80 to 90% of the hard work is done on data collection, whereas the others, 20% is based on your skills on how you express your data science problem. Okay, then the next one is number 4, EDA, exploratory data analysis. So this is where you have your beautiful graphs, you showcase your client that, oh, okay, so this is a trend. What is happening right now? Why is the trend like this? Why they should follow it? Okay, and then the next one is data modeling. Data modeling means the machine learning part. For today, we're just doing a simple linear regression and a data model. So don't have to worry too much about that. You all have all learned what is linear regression in secondary school. Yeah, but later I will explain it, okay, when we get to that. And then the last one is data evaluation. Today we won't really be covering this because the next workshop will be covering in depth on this, okay? Okay, so on to our example, HDB resale prices. Like I told you, we will be using the floor area in square per meter to predict resale price, okay? Very easy problem, very basic. Okay, so the next step is to import libraries. So the first step in any data science project is to import the libraries, the required libraries, okay? So there are a few libraries you will import. The first one is NumPy and Pandas. So NumPy is basically a library that's very useful for matrix manipulation and numerical manipulation, whereas Pandas is more for data frames, more to arrange your data, okay? Next one, for visualization, we have Matplotlib and seaborn. So Matplotlib is basically just, before Matplotlib, there was not really a library to actually visualize data. So when Matplotlib came, a lot of people used it lah. So basically all the data scientists use it. But then Matplotlib is a bit, if you look at the graphics, it's a bit washed out. So people actually created seaborn, which is built on top of Matplotlib, and the graphs there are a bit more beautiful, I would say. Okay, so the next one for machine learning. Today we only cover scikit-learn, which is the first machine learning library that you all will get into contact to. But for those who want to go deeper, there's Keras, which has high-level APIs to do your machine learning. It's basically for deep learning, high-level APIs for deep learning work. And then TensorFlow, it has both low and high-level APIs to do your machine learning work. And then PyTorch. Okay, PyTorch is, in the past, if you ask people whether they should do TensorFlow or whether they should do PyTorch, right? People will tell you TensorFlow, without a doubt. But then now the interest is starting to shift to PyTorch because PyTorch code is cleaner. Okay, so PyTorch, for those of you who don't know, PyTorch is built by Facebook, so there's a very clear structure to how the code is run, basically. So it's for those who want to learn deep learning, I would recommend learning PyTorch. Okay. But wait, start from Keras, because Keras is very easy to learn. Then after that, once you know how is it like, you prototype with Keras, then you go over to PyTorch. Okay? So yeah, this block of code is to import your libraries. Okay? Then afterwards, you will have to read in your data. So remember just now we dragged the 3 data over to the left side. Okay? Now I'll read them in. So to read data, right, you can see that over here, right? df variable name, so whatever you want to call the data frame, you read into use a read CSV function, and then the path of the file. So in this case, the path of the file is forward slash content forward slash resale price. So basically the name of the file, okay? Because if you look at here, you go up one level, these files are actually in content, okay? So the path of the file, don't have to worry so much for now. When you all get deeper into programming, you all learn more. You all be able to know. Actually, this is very easy, okay?
Text too small.
Oh, text too small. Okay, is this big enough for everyone? Okay, Okay. Can. So after you read in the data, so in this case, you read in the data, the resale data from 2012 to 2014 into this data frame. The next one, 2015 to 2016, and then 2017. So a lot of times, when data comes in different CSV files, right, you want to concatenate them together, correct? So it's easier to do analysis. It's easier for you to, it's easier for you to do analysis, okay? So recently I just went for this Grab challenge, Grab AI challenge competition. So they have their data in like 10 parts, okay? So for big companies, next time you're all working with big companies, you all need to know how to concatenate a lot of data together. So now you see here, okay, how do we concatenate our data? If you look carefully, right, I've give you all fill in the blanks. So these 3 blanks should be frames. What we mean by frames, right, is the data that you want to concatenate. It gives an array of the data you want to concatenate. The data frames, array of data frames that you want to concatenate. So in this case, the 3 data frames that you want to concatenate are df underscore 2012 underscore 2014. Then the next one is df underscore 2015 underscore 2016. And the last one, for the year 2017 only, df underscore 2017. Okay? So after you have, just now I forgot to mention, like this code, right? Remember to press Shift Enter to run this code. Okay? So whenever you run a cell, press Shift Enter. Okay? So for the reading of the files, you should also press Shift Enter. Either that, or you can press the play button over here. For those who like to play the GUI lah. Okay. Then next one. So once we have these frames, we have an array of data frames. We concatenate them, and you'll see the 2 arguments: ignore index and sort. Okay. So ignore index means when we set it to true, we don't use the initial index. We want to make a new index for the entire data frame. So you can see here it's 0, 1, 2, 3, 4 instead of the index that was predetermined for them. Okay? Then sort equal to false. We don't want to sort the data yet. Later we will sort the data. I'll teach you a function to sort data because this sort may sort according to different features, like different columns. Okay? Then you also have another function here, df.head. So df.head, what it does is it displays the first five rows of your data frame. Okay? But if you want to see more rows, you can always put in 4. For example, you want to see the first 4 rows, right? Then you'll see the first 4 rows. Okay, the number here, take note, is not 4 because in programming, most of the times, it starts from 0. So 0, 1, 2, 3, 4. So in the end, you still have 4 data frames, okay? And then, let's say, but if you have no argument, it will show 5, okay, by default. Then another function I want to introduce to you guys is df.shape. So what df.shape does is it finds out the shape of the data frame you have. So in this case, the left-hand side, see, you follow my pointer, left-hand side is the row, and then the right-hand side is the column. Okay? So there are roughly 141,000 rows inside this data frame. And then there are 11 columns. So 11 columns are basically your features. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So just to double check, we have 11 features and 141,000 rows. Okay? So the next one is so after you have your data frame, remember the next step I taught you guys is to do some data cleaning and data processing, right? So how do you do that? So normally in data science, right, you don't do this step so fast. You don't remove your features so fast. But in our case, since our problem statement is very simple, it's just to remove, it's just to find a relationship between floor area and resale price. We can remove all the unnecessary features. Because if you look on top, right, it's very hard to see, right? It's very hard to actually look at your data when there's so many features, so many columns. So we'll simplify it. We'll remove. So as you can see there, first you do the data frame that you want to drop, the columns, the features, and then the features you want to drop inside. Okay? And then lastly, the axis. So what this axis means is that you can either have 0 or 1. So 0 means that you'll drop the so 0 means that you'll drop the rows, whereas 1 means that you'll drop the columns. So for example here, all these things are from columns, right? Are from the columns, right? All these features are from the columns. So if I put 1, I will drop these features from it. So I press Shift Enter. You can see our data frame has changed from having 11 columns to only 7 columns. Because we removed 4 of them. Okay? Everyone so far, so good? Okay? Can So the next step is, just now I taught you about df, you'll show the last 5 of your data frame. So you can see the index here is 141,663 all the way to 141,667. Okay? So just now what do we do? When we find out the shape, we have 141,668 rows. Okay? Then minus 1 because it always starts from 0. Okay? Okay. At this point in time, who feels very lost? Who want me to repeat? Everyone understand? If you don't understand, just raise your hand, I will repeat myself. Okay. Which part do you not understand? It's okay? Okay. Okay, then we'll move on, okay? Okay, so the next step, after you have removed features unnecessary for your problem, the next step is to remove NaN values from your data frame. So what are NaN values? NaN values is, NaN stands for not a value. Okay? Not. I forgot what it stands for, but basically it just means that there are missing values inside your data frame. Okay, in this case, so what you always want to do is to remove these missing values. Either that, or you have a function based on other features to create a new value for that missing value. Okay. But in this case, since we are teaching the basics, again, there's a very easy way. You just do drop NA, and then all the missing values rows will be deleted. Okay. In this case, how many of you can tell me how many missing values rows are there? Anyone has the answer? I give you a hint. The hint is to look at the shape. Okay. Anyone want to try? How many missing value rows are there? Okay, 1. I hear 1. Okay. Who says 1? Raise your hand. Who says 0? Raise your hand. Okay. Who says 2? Who says 3? Huh? Who doesn't understand? Okay, who doesn't understand? Really? Who doesn't understand what I'm trying to ask? Okay, so basically, what I'm trying to ask, let me repeat, is the column. So far, so good? Okay, so what I'm trying to ask is, how many in our original data frame, how many rows in our original data frame actually have missing values? 0. Okay, I have 0. Raise your hand, who thinks it's 0? Okay. 1? More than 5? More than 2? Okay, no one. Okay, so the correct answer is 0. Okay, you know why? Because if you look at our shape before we did the drop NA, we have 141,668. But afterwards, after we did the drop NA, we still have the same amount of rows, 141,668. So what that means is that there are 0 rows that have missing values. So basically, I just want to tell you all that you all can use this function if you all want, but to remove missing values, yeah. But if it doesn't work, if the shape value doesn't change, it doesn't mean that it's not working. It just means that there's no missing values. Okay? Next, a new function I'll teach you all is .info. So what .info shows you is how many rows there are for each feature, each column, and then tell you what is the data type. So object, you see 4 objects here, right? They are strings. So what string means is it's just text. Okay, so their data type is just text. Then we have floor area, square meter, float. So float means a decimal number. Okay, for those who have programming background, you all will know this, but I'll just go through this for the benefit of people who don't know. Okay. Then the next one is least commanded integer 64 data type. That is basically just integer. That means no decimal, numbers without decimal places. Okay, whole numbers. And then yeah, resale price, same thing, float, decimal number. Okay. So next thing I'll teach you all is how to sort your data. So just now we went through why we put sort equal to false, right? Because how that function sorts, we may not know, okay? Because since there are so many features. So we use this function, sort underscore values instead. So in this function, sort underscore values, you can specify, sorry, I didn't, okay, remember to press shift enter after I go through. Okay, I always forget. So you can see your code run. Okay, so this sort underscore values, what it does is you can specify what you want to sort by. So in this case, we specify month, town, flat type, and then story range. So if you see here, right, let's say we take the first 10 rows, okay? So you can see it's sorted by town. So it starts from A, right? So it sorts Ang Mo Kio first, followed by the flat type. Sorry, sorts by month. Okay, month first. So 2012-03 all the way. So you expect March is the first one, the first date to come out. And then you have sort by town, which is Ang Mo Kio. And then you have flat type, which is 2 room of 3 room. You see the 2 rooms get sorted first before the 3 rooms. And then you have story range. So floor 1 to 5 get sorted before floor 6 to 10. Okay? Okay, can. So after that, I put another function here called .reset index. So what .reset index means is that, let's say we remove .reset index, okay? So .reset index, right? If you don't do .reset index, what will happen is that your index are not sorted again. So you have 1, 0, 3, 5, 6, 7. So it's not sorted. The index are not reorganized. So when we do reset index, when you do .reset index, right, you can see 0, 1, 2, 3, 4. It follows nicely again. And some of you may wonder why I put this drop equal to true. So if you try, right, you put drop equal to false, which is by default drop equal to false, you have a new index column. So you don't want that to happen. That's why you put drop equal to true. Okay? Understand? Okay. So you can see here, just now since we dropped the columns, we have 7 columns left instead of 11. Yeah, you can see in the shape. Okay, next I'll teach you all how to change the data type of a certain feature, of a certain column. So as you can see here, just now I taught you all the info function. So info function, you'll see there's object, float, in, and float. But what do you think is a more accurate data type for these functions? So for month, any suggestions? What should we change it to? Month is a date, right? So in Pandas, they will have all these data types. So we have date time 64. Okay? So in this case, we should change month to a date time data type. And then for town, at first it may seem like is just a text, just a string. Okay? But if you think about it further, there are only a finite number of towns, correct? So you can change it into a category data type. This is something that Pandas has. Python does not have it by default. So when you have a category data type, you can do a lot of things with it. Later I will bring you all through how you can manipulate that and give a lot of beautiful graphs. And then flat type, also we should have a category data type because there are only finite amounts of flat type. Story range, likewise of story range also. Then for 4 areas underscore square meter, we have a float data type. But if you look, if you look here, right, all our floor area features, right, have 0.0. Okay. I've looked through the data type, the data frame. All of them have 0.0. None of them has like 0.1 or like 0.6. So in this case, sometimes as a programmer, as a data scientist, you want to save space. So you change it to an integer data type. Okay? And then, so it's easier to work with also. And then resale price also, you look carefully, it's all 0.0. So we should just change it to integer 64. Okay? Whole number. Okay, so this is how we change data types. So just now, town, what do we change to? What do we change town to? Come, anyone just shout out the answer. Yeah, category, okay? Okay, for flat type, what do we change to? Category also, right? Okay. Story range, likewise. And then for the last two, we change to integer type, okay? So after I run this line of code, we have successfully changed all these data types. So if you can see what the function is the function is .s_type. So .s_type, then there's a dictionary inside, which has all the data, all the columns, and then the key is the column, then the value is what data type you're going to change to. Okay? Anyone lost at this point? Raise your hand. Okay. So far, it's just applying these functions, okay? So at the start, you all may think that, oh, it's very hard to remember all these arguments, different values to put inside to get what you want, right? But as you go further, you will kind of get used to it, okay? So the next thing is for least comments date. Least comments date, right, can convert to date time. Because if you notice carefully, right, least comments date is actually year. So if you just convert straight away, right, the data will be a bit weird lah, because they will convert by the minutes first. Seconds first, then minutes first, then minutes next. So the data basically will get distorted. So in this case, we just use this function dot to date time to convert, and the format is just year. Okay. So for this, you don't have to worry about it. I just want to show you all this. The next thing on data science, you don't want to just rely on the data you have collected. You want to use the data collected to make a new feature that you think is more accurate and represents the problem better, correct? So for example, you want to find out a relationship between x and y, right? But y is this is very mathematical. Okay, y is like exponential curve, correct? So, but then if you use a log function on y, exponential becomes a bit more linear, correct? So it's easier to analyze it. So this is why you want to do feature engineering, to make sense of the problem, make more sense of the problem based on your own context knowledge. Okay. So in this case, we want to create a new feature called remaining list. So remaining list, we want to minus. What do we do? So we create this new feature remaining list. What remaining list means is that we need to minus the month, which is the date that the flat was sold, from least commence date. Okay, so now we'll do that. Month and least commence date. Okay. Then we run, we have the remaining list in like seconds. Okay. So this is a more accurate measure because initially, remember, we only have the month that the flat was sold, and also the lease commence date. So why not we make a new feature, like how many years is left for the flat? Okay, so that's a more accurate feature to determine to kind of predict resale price. But this is just extra knowledge. We will not be using this feature for the prediction in our analysis, in our data modeling. Okay. Then another thing I want to teach, another thing that's extra, I'll teach you all is DF sorted. Okay, that's why we will drop the least commence date feature. Okay. So we just drop again, because. Okay. Oh, we dropped the least commence date. Okay, I dropped it. Then I rerun it. That's why it cannot be found. Okay, that's the reason why. Okay, so next thing, when we want to double check whether we have really changed all our data types, we can just shift and use the, so month has now been changed to date time, town category, flat type category, story range category, and then floor area and resale price is an integer now, and then our remaining list is an object. Actually, we can change that. So you all have learned how to change that, right? So how to change that is, okay, just type inside here. What's our data type? df sorted dot s type. Dot s type. Then you have your dictionary. Your key is remaining list. And then your value will be date time. Okay. Oh wait, date time 64. Like that. Okay. Oh wait, okay. So the reason why it was not recorded is because we did not save. Here. We did not save this inside DF sorted. Okay, so now if we do this, we'll have the new data type, date time for remaining list. Okay, so okay, the next thing, just to double check again, we have df dot head to see what's our data. Okay, you can see. Okay, next, I'll teach you all something called df underscore sorted dot describe. Okay, so what this means is that we save this describe. So describe basically gives you a summary of all the numerical data. Okay, so in this case we have all the numerical data. So we have floor area and resale price. Those two are our numerical data, right? So what will happen is that when we run describe, they'll find out how many columns there are. Firstly, second, the mean. So mean is the average value of all the rows, all the values inside. Standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and the maximum value. So this is also very good for data analysis. So this can give you a rough gauge of what your data is about. Like, is it very skewed towards one side? Does it have a normal distribution? Okay, you can't really tell that, but you can kind of see it. Okay. And then, so But if you cannot visualize it, like let's say people don't have a statistics background, don't have a maths background, they can't really visualize it. You can do something called a box plot. Okay? So now we have gone on to the next step, which is visualization. So visualization is how to put this data and try to visualize it, express data basically. Okay, so that people can understand. So in this case, how you understand a box plot, for those of you who don't know what a box plot is basically a plot, and then the left hand corner will dictate will tell you the minimum, then the right hand corner will tell you the maximum, and then the first quartile will be here, medium, the 50th percentile, and then the 75th percentile, okay? Then there will be outliers, okay? So those that are not within here are the outliers. So once we try so we can now try. So the function to visualize a box plot is dot box plot, very easy. SNS, as we see previously, we import our seaborn as SNS. You see, okay, you see, we import seaborn as SNS. So if you want to call functions in seaborn, you have to use SNS dot something, okay? All the functions in seaborn. Okay, so as you can see here, SNS dot box plot, because we are using a function in seaborn library, then df sorted.
Can you do the 4 5 cells before 2.4? Some people having problems.
4 5 what?
Like 4 or 5 cells before 2.4.
Oh, when? Oh. Okay, so we have a question, how to change it to time delta data type. So some of you are more advanced. Basically it's the same, actually it's around the same, okay? So actually as a coder, right, sometimes you may not know the answer to a problem. You can always Google it. It will be on Stack Overflow. There are people who have have experienced the same problem before, and they will have answers. Okay, but if you want to change, in that sense, wait, you are asking when to change or how to change? How to change?
5 cells before 2.4.
Myself. Which one? Oh, do feature.
Because you got the errors and they couldn't figure out. So you got these errors and they don't know what to do.
Oh, okay. Okay. Yeah, because they run the two things together. Like that. Okay. Yeah. Okay. So I forgot. Some of you all may have some problems because may have some errors because I ran that column twice. So I ran the drop column twice. So what that means is that when I try to drop again, right, the same column is not found. That's why there was an error. Okay. So to do that, go back to solve the error. Go back to 2.3.4. So what this will do, right, is they'll put the original data frame into df sorted after they have sorted. Okay? So you get the original data frame again. We do a sorted. Okay? We change the data type. And then we change the data type again. Okay? Of the least common state. So just run everything once. So this one also run once. Okay? Then after that, this function, right, only run once. Or you can choose not to run it. Then it will be in your data frame. Okay, in this case, we don't run it so that we won't have the problem. Okay? And then, yeah, just run from here. Run from the df stats. Okay? And then we'll go back to box plot. Everyone okay? Still got any problems? Cannot run, got error.
There's an error that says can't change time delta to delta. In the, I'll tell you the cell. Yeah, go down. It's the remaining lease, date time 64.
Can't change it.
Yeah.
Yeah.
Yeah, because I didn't.
Oh, this one is it?
Yeah. Remaining, yeah, remaining. No, not this one. Go down.
Go down.
You go down. Go down. What the hell? Go up. 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 Up.
Okay, wait. Anyone else has the same problem? If anyone has problem, raise your hand. Okay, what problems do you all have? Which part are you stuck at?
Third cell above 2.4.
Okay, I think that one.
Dot
Yeah, I
data
changed
is
it.
probably adding another cell.
Okay, ask me to rerun from this one df software df software df software dot slide. And then after that remove this. So just now I did this right.
You remove the cell?
This one, okay. So df software dot slide.
Yeah.
Before that, remove that.
Okay.
Yeah. Okay, we'll continue, okay? So the next one is box plot, okay? So you'll see two fill in the blanks here. So this blank will tell us what we want to analyze. So in this case, we want to analyze resale prices. So we type resale price, sorry, and then H. Oh, there's no resale price here. Oh, there's 2S. Okay, so you'll see this. Okay, so just now, as we have discussed, these are all the outliers. You can see it's very skewed. There are a lot of outliers. There are many houses that resell for very expensive prices. Then there is this is the 50th percentile, which is around 42,000, around there. 420,000. And then we have the minimum, which is around, okay, I can't really estimate, but this gives you a visual representation of the data of resale price. We can also change it to floor area. You can see it's better than, it's less skewed as compared to our resale price. Okay? And then next we'll move on to this plot. So what this plot is basically a kernel density estimate. Okay? So how you look at this graph is, it will basically be like a histogram. Okay? So histogram will have different bins where they will count how many data is within that range. Okay, so it shows something like this. So different bins, we show fourth cell.
First cell of 2.4. Visualization first cell.
Oh, okay. Okay.
First fourth cell. No, I don't know.
Okay, let's continue. So we have our kernel density estimate. So what this means is that basically they try to plot. You can see here, right, the red graphs are all the beans. So those with higher, higher frequency will have a higher amplitude. Then after that, they will combine all of these graphs, and then you'll get the blue graph. So this is what tells you how frequent it is. How frequent it is at, for example, value 10. So the maximum point is 10, right? Oh, is it 10? No, maximum value is around 8. So how frequent is it that is at the maximum value? Okay? It's around 8. Sorry, it's very frequent. The 8th value is very frequent. 8 data, okay? So you can see here, if we try to DF sort our resale price, you can see that most of the prices are centered around 400k, 400,000, okay? And this is in line with our box plot. So it's basically like a curve of our box plot, if you think about it, okay? So our box plot for resale price, you can see it's also centered around 400,000, and this reflected in our graph, in our kernel density estimation plot, okay, which uses the function dSplot. Okay, you can also change the color. So for those artsy-fartsy people here, you can change it to, for the R is red, you can change it to G, which is green. You want to make your graph look nicer. Okay, you can also change to blue. Actually, there are a lot of colors that you can choose from. You just have to search graph color and put in the correct argument for it. Okay, moving on, next one we have is violin plot. Okay, so violin plot, it's basically like a kernel density estimation plot combined with a box plot. Okay, so you have your box plot inside in the middle, and then you have your kernel density plot outside. Okay, so now let's try to plot resale price. See, we can see very clearly that there's a box plot inside, just that it's very thin, and then the kernel density plot, which is the same as what we plotted just now. Okay, the same shape. Okay. At this point in time, anyone feels very lost? Raise up your hand. Who feels very lost? Like you don't understand what we've been doing for the past hour.
Asking if you're going too slow or too fast.
Okay. Am I going too fast? If you think, okay, now I'm going to ask a question. If I'm going too fast or I'm going too slow. Okay, those of you who think I'm going too fast, raise up your hand. Or going too fast. Going too slow? Raise up your hand. Also, the others think I'm just nice. Okay. We'll follow this speed, okay? This pace. Okay, so next, I'll teach you all something extra, which is like, it's quite cool actually. I like it myself. It's very cool. So what we're going to do now is, we're going to group these graphs together. So basically what I've been doing, right, is so far is, you see, and I didn't explain to you guys what this code means, this first line, before we plot every graph means, correct? So now we're going to use this and understand why we use this line of code. Okay? So this part is where it gets a bit more interesting. Okay? So you're going to learn how to do this, how to group these graphs together in one cell. Okay? Okay, so the first part, we don't want to keep on, you look at it, look above, right? We keep on typing df sorted resale price to go inside resale price, correct? We don't want to do that all the time. So in this case, we just save it inside a variable. So resale price equals df sorted resale price. So every time we use resale price, we actually mean df sorted resale price, okay? Then every time we do floor area square meter, we actually mean going to df sorted and finding the floor area square meter column, okay? So now we'll do a subplot. So we use a subplot function. Now I'll explain to you what a subplot function means. So basically what this means is that f is your figure, okay? It's just a canvas. So basically it's just a canvas, okay? And then axis is which part of the canvas you want to go to, okay? So in this case, the subplots function, we want to have a 2 by 3 column, correct? 2 by 3 canvas, correct? So 2 rows, 3 columns, okay? So we'll just change these values to 2 rows, 3 columns. Okay? Then the figure size, I mean that's quite self-explanatory. How big do you want the figure to be, okay? And then how big you want the canvas to be, And then next we have sns.boxplot. So what we learned before, right? Boxplot, gisplot, and violin plot. But now there's an extra thing, AX. So AX is the argument whereby where you want to put your graph on the canvas, on F, okay? So AX equal axis 0, 0. So this refers to the first index, this place, 0th row, 0th column, okay? Understand? So what should this be? What should this graph be? Anyone has an answer? When I put it here, what do we put? Not 0, 0. I heard 0, 0. 0, 0 is here. If you want to do the graph here, what do we do? 0, 1, correct. Okay. Here? 0, 2, correct. How about here? 1, 0. Okay, can. You guys are getting it. Okay, so you can see here 0, 0, where we do this graph. 0, 1, we do this graph. 0, 2, we do this graph. Okay. So now, if you want to put the box plot just below the box plot, or the resale price box plot just below the box plot of floor area square meter, you will put 1, 0. Okay. Then the next one, the violin, this plot 1, 1. Okay. Then the last one, the violin plot 1, 2. Okay. So once you do this, you will get your beautiful graph. Oh no, there's an error. Why? Oh, resale price is not defined. Okay, because I didn't run the first part, right? So I run this part. Then I run the graph function again, the graph cell again. Okay, it takes a while. Okay, then you'll see a beautiful graph. Okay, you realize, right, that this plot, right, doesn't have the kernel density estimation plot. That's because we put KD to be false. But actually, if you guys want it, we can change it to true. Capital letter true, okay? And then you'll see, see for this graph, the one that we put true, you can see the kernel density estimation. Okay? So, for this graphs part, this visualization part, right, actually, if you are just doing the same few graphs, to be honest, it's just a copy-paste. It's just changing the arguments, what you want to do. So, this is actually by far the easiest part of data science. Okay? But the hard part is what you want to visualize, the data that you want to visualize. You have to make it in such a format whereby you can put it inside this graph. Okay? So it's the data cleaning, the data processing. Okay. The next one we'll do is, previously what we have done is we are doing analysis on like single variables, like one feature only, like resale price and then floor area. Okay? So now we'll do 2 of them, okay, at the same time. So this is called a bivariate analysis or multivariate analysis. So you can see here, as you can see here, we have join plot. That's the first function. Okay, so what join plot does is, you don't have to, like I said, you don't have to really know how to type it out from memory. You just have to know what it does and know which argument to change so that you can get the same graph, okay? So in this case, we have x equal floor area, then y equal resale price. Then you can see here, resale price, okay, let me make this smaller. Okay, resale price, we have, so x equal floor area, y equal resale price, and df, data equal data sorted. So what it's telling the function to do is to go inside this data frame, the data which is df sorted, and find these 2 columns, floor area and resale price, and then create this join plot. Okay, so some of you may be wondering, okay, the height is quite self-explanatory. It's just basically how big the graph is. Then h colors is w. So if we don't do edge colors, right, what will happen is that, okay, let's say we take out edge colors. It will be very, how to say, very messy. So we can't really look at the different points carefully. Okay, so that's why we do edge colors equal to W, which is white. Okay, so let's try it again. Okay, much better, right? So we can now see our data more carefully. Analyze our data better. Okay, because the edge are white. So what it means is that for every point, right, it's blue color, correct? But the edge is white color. That's why you can see it so clearly. Okay. Then you have your kernel density your histogram at the side. So you can see this is the histogram for floor area. This is the histogram for resale price. Okay. So this is basically like plotting those two together on the x and y axis. Okay. And then next, we can also do a heat map. Okay. But this heat map in particular will do a heat map of the correlation between these two variables, these two features, sorry. So you see these two blanks, right? We'll just do floor area. So we're going to compare these two, the correlation between these two. Floor area. Okay, so why the correlation is important, right? Is because sometimes we're going to find out whether a certain feature is important to the feature we want to predict. Okay, so we can use this heat map to find out the correlation, see it better. Okay, for now, right, you can see if we do this heat map, it's just going to be two features, so there's nothing much to compare. But let's say if you do more features, right, you can see based on the color, for example, there's very strong positive correlation, it's going to be white color, and if there's very strong negative correlation, it's going to be black in color. Okay, so floor area square meter here, and then the next blank we'll put resale price. Okay, so what this does is it gives us the data frame. So join df equal concatenate. So we're using the same thing. So these are the two frames, just now what we used previously. And then axis 1, so it's the features column. Join axis. So what this does is it joins the axis of, basically it's just join axis according to floor area dot index. Okay? Then after that, you find out join df dot correlation, which is going to be like this. So what join df is, right, without the correlation, it's going to look like this. So it basically is like a data frame of, for example, when floor area is 44, resale price is this amount. When floor area is 45, resale price is 250,000, something like that. Then we just use the dot CORR. Then we will get the correlation. Okay? So the correlation is here. So you can see, right, the correlation between floor area and floor area, the same feature, is always 1. Because it's the same value basically. So that there's a very strong positive correlation. It's exactly 1. Then same thing goes for resale price and resale price, also 1. Then you can see here, when you plot the heat map, right, we will plot what we want, the data frame we want to plot. And then after that, we stipulate the minimum and maximum values. So right now, if we can also change these values, just that it's easier to work with -1 and 0.1, okay? Because when you find correlation, it's always a number between -1 and 1, okay? That's why if we do 0.2f, right, 0.2f will give you, for example, now we have 0.67. If you do 0.3f, it will be 3 decimal place. Then you can see it's 0.667. So it depends on the accuracy you want. Okay? So next part is to analyze categories. Okay, so just now I mentioned that sometimes it may be more beneficial to convert the data type to a category data type, right? So this is where it comes in handy. So as you can see here, if you want to do category plots, right, it's something called cat plot, very easy to remember, cat plot. Then you do your y equal to flat type, which is what you want. So for example, now we want to categorize flat type. And since it's a category data type, we can plot this graph. Data, we get it from df sorted, okay, as usual. Kind, you got to count. This is very important. So you want it to count the amount of data, the amount of rows that are flat type inside these categories. Okay. So as you can see, our graph is like that. So actually the flats that are being sold from 2014 to 2017, 2014, right? Forgot. Okay. Okay. Now just take it as 2014 because I forgot when is the data until. Or is it 2012? Yeah. Okay. So for example, the flats that are being sold from 2012 to 2017, right, are mostly 4-room flats. So 1-room flats don't really get sold at all. And then 3-room flat and 5-room flats are a bit more, but the most popular are 4-room flats. So maybe some of you all know the reason to this, I don't know, but that's why we do data science. We do exploratory analysis to find out these trends, and after that we try to explain it. Try to find a reasonable explanation for it. Okay? Next one, we can do it for story range. Okay? Then now, can you tell me what is this? So what are you supposed to put here? The data frame that we want to get the data from, right? So it's df sorted. The kind, so we want to count how many of each is inside. We want to count how many is inside each category, right? How many rows are inside each category. So we change the kind to count. Okay? So we'll get this graph. Okay, so as you can see, right, the flats that are being sold mostly are 4th to 6th floor. I don't know why. Okay, don't ask me. But this is just the trend. Then I don't know why 6th to 10th floor is so little, 1 to 5th floor is so little. But as you can see, 1st to 3rd floor is quite a lot. Maybe because it's very noisy, that's why people want to resell their house to get higher floors. I don't know. Okay, just a conjecture. Okay, then now I'll teach you all something extra. Okay, so you all see this plot, right? So order, right? You can actually specify the order. Okay? So in this case, right, we specify the order to be Bishan, Bukit Timah, and Marine Parade. In this case of town. Okay? That's why we'll get this tree. Okay, but let's say we want to sort our we want to sort, right? According to we want to sort, right? So, okay, you all know what's comment. So basically, what comment means is that you all can disregard that line when you run the code. So to comment something, right, just press, for Mac users, press Command / for Windows users, press Control / then you'll comment. Or either that, or you can just type a hash in front of the line you want to comment on. Okay? So now what I will do, right, is show you all how to sort it. See, this is sorted, okay? When we do the graph, it's sorted based on what is the count. Okay, so I'll just run you through this code. But if you don't understand this code, it's okay. Like I said, graphs are basically just the same thing. You just have to know the code, just to know how to use it. Understand how it's used. Don't have to remember how to write it. Okay. So this one, the order is df sorted dot group by town. So what this will do is, it will give you an object. Okay. So you need to use, okay, so what an object looks like. Let me show you guys. Okay, so what an object looks like, right? You cannot display an object, okay? So you just see like that is an object, okay? So that's why we need to use dot size.
Can you switch your Colab to light mode? It's in dark mode right now, so you can't see the labels.
Oh, can't see them.
We can't see the label, but it's in dark mode.
Oh, okay. Okay. Okay, can. So you can see this is the object, right? Let's say we want to do, don't want the object, so we have to do dot size. Okay, so dot size gives you, so sometimes what you do is you just analyze the code, then you will understand what it does. So size gives you all the different counts that you have for the category, okay? So it basically does the cat plot thing for you, the count thing for you, okay? Now then after you do size, right, you will do to frame n to make it to a data frame, okay? This is like a function to make it a data frame. Then the n argument is to specify what is the count column going to be. So now in this case the count column will become n. It will be named n. Okay, you see? Count column will be named n. Okay? Then after that, you will reset index because now there's no index at all. Okay, so when we want to change when we want to sort values, right, we must always have an index to sort with. Okay, so we will reset index, then we will sort values of 1 to n. Then ascending we go to false, so that means it's from the highest to the lowest. Okay? Okay, so when we do this, then we'll get this data frame. Okay? So to get this data frame and put it into order, so what order wants, right? Order requires a list as an argument. Okay, so to convert it to a list, right, you need to do order town first. Okay, so order town shows what is inside town. So these are inside town, correct? Jurong West in this order, and then you do to list. So it will become a list. Okay, so it becomes something like this. So what we are doing right in actual fact is to take this entire list, right, and put it inside here. Okay, so that's what this code is doing. Okay, so you see you can order town equal to list, then we assign it to order. Then this is the order. Okay, then you will get this code. Okay, anyone very lost? Don't understand what I'm talking about? Okay. Oh, I asked anyone very lost. Okay, so I'll explain again, okay? But actually, you guys don't have to really know this, okay? Because this is just, like I said, graph, right? Graphs are very basic. So what you need to do is you just need to understand what the arguments are. So I'll just explain this extra part again. So what this will do, right? So the first function, dot group by. What dot group by will do is it will group by the town. Okay? When it groups by town, you put dot size to find out each value inside the count for each town. Okay? Once you have the count for each town, you convert it to a data frame and you name the number column n. So after you name the number column n, you put reset index to kind of like add an index inside so that you can sort your values. Because if you don't have an index, you cannot sort your values. Then you sort your values according to n. So you see, you sort your values according to n, and then ascending is false. So that means it's in descending order, okay? Yeah. Okay, can If any of you still don't understand or want to discuss this after this workshop, you can come to me, okay? Okay, the next step, and the last step basically, is data modeling. Actually, the second last step, because we will be going through evaluation today. So the second last step will be data modeling. But in this case, our last step. So just now I told you that we'll be doing linear regression. So what linear regression is basically you all learned graphs before, right? Like basic maths, y equal mx plus c. It's basically just that, simple as that. Okay? So your x will be your your x will be your dependent variable. Yeah, and then your m will be your b will be your gradient, then your a will be your intercept. Okay? Then your y will be the independent variable. Okay? So what you'll do is how linear regression basically works, right, is they will find the sum of squared errors, okay, and try to minimize it. So you see this green line? So they will try to plot a line such that it will reduce the distance between the point and the line. and the plotted line, okay? So it just does this in a lot of iterations such that it gets this best fit line. So I'm sure a lot of you all have drawn best fit line in secondary school, right? So it's the same thing, just that now the computer does it for you, okay? Okay, so in data modeling, right, it's very important for you to, there are two steps basically, the training step and then the testing step. Because if you just train your data, right, on the whole data set that you have, it's going to be very hard for you to test it out. Okay, so what people do, what data scientists do is that they split their data into training set and test set. So for this code, right, for all this code, right, your values will be different from mine. Okay, so first thing, import a library, which you have already done earlier, but just to tell you all, these are the libraries you want to import. Okay? Then after we import the library, we will do X, capital X, okay? I don't know why, but data scientists like to use capital X for the X. Okay, so later when you all type, just use capital X, okay? And then equal df sorted, floor area square meter, dot values, dot reshape. So what this does is, it gets the values inside all of this, correct, as an array, and then they reshape the array. Okay, because if you don't reshape your data, sometimes it may work, sometimes it doesn't. Okay, so you just have to play with it. Okay, sometimes if it doesn't work without doing dot values dot reshape, right, then you do use this function. So you can just search online Stack Overflow what this function does, so you understand it better. Okay, but for this purpose, for this workshop purpose, I'm not gonna elaborate further. Then after that, you will do train test split. You use this function called train test split, which we imported from scikit-learn model selection. So you do train test split, we'll split x and y. And then the test size will be 0.2. So what this means is that 20% of our data set will be used as our test set. You can do test size equal a numerical value as well, if you really want to do it by percentage. So for example, if you want to do test size 1000, you can do it also. Okay, but in this case, we'll do test set 20%. Then test set 20% will return four data frames. Four arrays. So the first array will be just save it to x train, second one x test, third one y train, fourth one y test. So okay, so after that we will just print out the shape for the train test set and the test set. Yeah, the training data set and the test data set. Okay, so you can see here, right, the train data set for the x values are 113,000. Same for the y train data, 113,000. Then test set is 28334. Okay, so if you look carefully, right, it's roughly 25% of this, because this is 20% of the data set. So this is 80% of the data set. So this is 4 times more of train set is 4 times more of test set. Okay? Can And then now we'll look at the train data. So we'll train the model and then try to visualize how the model works. Okay? So we'll run this. Okay, so it cannot run yet. So what you want to do here, right, is you want to fit the model first.
Ask if anyone has a doubt.
Huh?
Ask if anyone has a doubt. Questions.
Oh, okay. So far, anyone has any questions? No? If you have questions, don't be shy, just raise it up. It's better if I explain it to you than your friends explain it to you. Then after that, some misconceptions may arise. Okay, so anyone has any questions? Anything to ask? Okay, don't have Okay. So first we need to create a linear regression object. So how to do this is just do linear regression. What is it called? What's that called? What's that? Oh, bracket. Okay, open and close bracket. Yeah. And then after that, you save it to linrec. Okay. So this linrec object will feed. What we're going to feed? We're going to feed our x train. Remember this capital X and y train. Okay, once we fit our X train and Y train, can run this, and then you will see, we'll print out the intercept and the coefficient. Okay, so to assess the intercept, just use the intercept underscore underscore method, and to assess the coefficient, intercept underscore only. And then to assess the coefficient, you just use the coefficient COEF underscore method. Okay, your answers, your values here, right, B and A, right, will probably be different from mine because the train test split function is random. So what that means is that you all will have different train values, train data set compared to mine. Okay, even though the count is the same. Okay, so your values will probably be different from mine. And then next thing, we will just need to plot the graph. So you can see here, regression line equal X train, then regression Y equal to, this basically just redoing the Y equal mx plus c. Okay? So what this does is that we want to find out the X coordinate and the Y coordinate of our what do you call that? Of our data model line. Then after that, you can see we scatter. So these are all the data points for X train and Y train. Each colors equal white, just like what we have just now. So this is what we plot just now. Then we plot the line, not scatter. We plot the line. We plot our regression line. So this is the regression line we got from this training data set. Okay, so it looks something like this. So this is the best fit line that is optimized for this train data set. Okay. So we want to test it out. How does it look on our test data set? So if you look at this, right, this data here, right, these points here, right, these blue points here are a bit different from the green points. The green points are from our test data set. For example, here you see for me, right, you guys may be different. For me, there are 2 points here, right? Then, but here there are like so many points. It's like 1 on top, 1 below for my test data set, but here there's 2 below. So it's different. It's completely different. Okay. So you plot it out. Then plot the points. Okay. So this is how you visualize what is predicted and what is the actual value. Okay. And then yeah, the last one is to evaluate your model. Okay, you can use mean square error. Okay, sorry, we didn't run this part. Yeah, I said I'm not going to cover evaluation of the model, but I just put a small code there so you'll understand. So basically how you evaluate a model is using something called, inside the metrics library, there's something called, in the scikit-learn library, there's something called metrics. Then inside metrics, there's a function called mean square error. So you just put what we have here, Y test and resale price prediction, which is what we have here, resale price prediction, linrec.predict. So to predict the value, we just put X test inside, and this will be the Y value that's predicted. Okay? To draw this graph. Then afterwards, yeah, so this is a metric For those of you who want to find out the mean square root error, right, you can try doing this. NP means numpy dot square root sqrt. So it's basically like this. So on average, right, the distance from the predicted point to the actual value is around 100,000. So as you can see, right, this data model is probably not very efficient in predicting resale price. Okay, so this is the challenge I'm going to pose to you all. Try to improve this model using the other features that we have dropped just now. Okay, so this is the end of workshop. But then just some further learning for those of you who want to upgrade yourself. I give you all some things to look through. So the first thing is, what are some interesting questions that you all can look for using the same data set? So for example, what's the best worst times of the year to sell your house, and by how much do these prices change? So this is another problem statement that you can work on. Another one is, how's the travel time from different locations to central area affecting HDB prices? Okay, so this second question, you'll probably have to get another data set from Google. Go Google another data set and try to combine the two together and find out something that is useful to answer this question. Okay. Alternatively, if you don't like Singapore HDB prices, resale prices, you can always look for other data sets. So in this case, we can look for Airbnb Seattle. So for those who knows what's Airbnb, right, it's quite similar to HDB. It's like in a way, it's like a house also lah. But there are much more features to consider. There are much more data points to consider. So that's another good place to start off from. There's also for those of you who want to very environmentally friendly, you can look at Singapore's pollution level. I linked it here already. You can look at the data set. Then earlier today, I mentioned that we are using Collab because Anaconda requires a lot of time to set up, correct? So for those of you who don't want to use Google, for some reason you hate Google, I don't know, you can use Anaconda. So Anaconda will work on your local machine. Okay, so you don't have to worry so much. Then if you look on top, right, I actually have, so after you download Anaconda, right, you can just open this same file. No need to upload it to Google Drive. And then, yeah, you can just, to import your data, the path, I already made it clear here already. So you just uncomment this part and comment this part. Okay? Then you can run it on your own local machine. Okay? Okay, so after you download Anaconda, so why is it important to download Anaconda? Anaconda has some of the more useful libraries for data science. Okay, the first thing is Jupyter Notebook, which looks something like Colab. It has cells, but it's, in my opinion, it's a bit cleaner lah. Okay. Then it has Jupyter Lab, which means it will do a local host on your computer to upload it online. So it's like just access it from local host. Access this Jupyter Notebook from local host. And then after that, RStudio, for those who think that today is very tough, you want to learn programming, but you want to do data science, but Python is too tough for you, you can try RStudio. RStudio is a bit easier in terms of programming. Then there's one thing that is very useful. So for programming, those who want to go to programming, right, you can try out Visual Studio Code. Visual Studio Code is not really a IDE, it's a code editor, but it's one of the more useful ones out there. There are a lot of extensions that you can download to make your life easier. So, yeah. And then after that, for those who want to download Anaconda, right, I've already put in a link to the step-by-step guide from DataCamp to make your life easier lah, okay? Because yeah, I want to help you guys also go into data science if you're interested. And then the last thing is you can earn money from this, okay? So those people who are a bit more who like to see money, right, can get rewarded also. There's this place called Kaggle. So Kaggle is where you can join competitions in a team or either in a team or alone lah. Okay, then you all can win prize money. But then the prize money, right, I've seen up to like actually post to Kaggle for the open source community to solve. So that means people in their company cannot even solve it, or they take too long to solve, or it's not worth their resources. That's why they put it as a competition. And then yeah, I recommend you all to check out the getting started category first. Okay? Yep. Okay, then thank you so much for coming here today. I hope you all learned something. And yeah, I'll give it to Laksh.
Thank you, Wilson. Thank you, Wilson. Thank you, everybody, for coming down tonight. Before you leave, we have a few things to bring to your attention. So when we asked you guys to raise your hands to ask if you had any doubts, I didn't see you guys raise hands, but I can sense that most of you had doubts. And it's understandable because data science, you can't learn in 2 hours, and it's a bit too fast to learn everything. So for your help, we have done a live recording of today's workshop, and we will be uploading it on YouTube to our YouTube channel. So you can scan that QR code and watch the workshop anytime you want. And we will also be uploading written material for this workshop on our Medium page. So you can scan that QR code and go through the written material of this workshop if you want. If you want information about any of our events or our workshops, you can scan the QR code for our Telegram channel and our Medium page. Okay, so I'll just wait for you guys to scan the QR codes, and I have two more things to do with this.
It's mostly like they are kind of confused when you're like guiding them through. You figure out how it's
Okay.
Zhu, do you want to do shirt sales? Shirt sales.
Okay. Okay, so just now, all of you all, right, I feel like, personally, I feel you all are quite shy. I don't know whether it's the uh, Asian culture or what, but then you all don't dare to raise up your hands to ask questions. So now for these shy people, you all can come down and ask if you all want to, okay? Or send me an email. Yeah, if you look at the top of the workshop or the GitHub page, right, there's a
Which is yours?
yeah.
HTML.
Yeah. You can see my GitHub page is here, and then okay, yeah. Email your questions to me, okay? It's here, okay? Inside the notebook. Just click this button. It will bring you to mail me lah, basically. Then I will try to reply, but try not to email me during exam time. Okay? I need to study also. Yeah. Okay, that's all.
Alright, so I'll switch on the QR codes. So if you weren't already tired of QR codes, we have one more QR code for you. This is the workshop feedback form. So it would help us out a lot to fill the feedback form, and we can improve our workshops based on how you guys feel about this workshop. So I will for you guys to scan this QR code. And then one more thing after that. If you can't